Hi, in this short video, I want to cover some of the main concepts presented in Chapter 4. Chapter 4 deals with this notion of the process of modeling, and it breaks it down into basically four main steps. One is to plan, and we'll talk about this, but the key thing here is to avoid opening your laptop during the planning stage. The best modeling occurs just with pencil and paper in terms of organizing the logic, speculating on what the various relationships are within a model. So plan, we'll talk about that here in a second. Second is then to build, you want to scale up. Start with some of the basic elements of the model and add complexity as you go. And then, of course, test it. And test it means start to examine extreme values and make sure it's delivering what you would expect to be the kinds of outputs that you imagine. And then, of course, finally, you move into the analyze stage. But again, you only get to that analyze stage once you have built a model that you have validated as being accurate. So let's talk about some of these elements in particular. And here we go. So the first one, sort of principle presented in the chapter says, hey, where do you start? You're sitting there, you've been presented this sort of fuzzy, hazy problem with a business or whatever, and it's like, well, how do I really even get started? And years ago, I used to coach chess at my kids' elementary school, and it turns out that one of the key pieces of advice to a young kid learning to play chess is to sit on their hands. And the reason for that is the following: is when kids are playing chess, they're so eager to start making moves as quickly as possible. And if you get them to sit on their hands, then basically that prevents them from moving too quickly without thinking. And so that notion of sitting on their hands, the idea was sit on your hands, look at the board, think through all the possible moves, and only once when you've decided the best move to take, then take your hand and make the move. And so it turns out this little sort of interruption in terms of their hurried default approach was really helpful. The same thing applies to spreadsheet-based modeling. We're often so anxious to get a spreadsheet model going that we open the spreadsheet, we start throwing data in there, start putting in formulas and so forth, without really sitting back and thinking about the logic of the model and in particular, what you're even trying to do with the model. And that sort of begs this next question, which is, where do I want to end up? So you imagine, once you're presented with the business problem, you just imagine what would be the screen or the outputs that a great model would have. And this is really good because, again, it's keeping you focused on the end product. And also, it turns out, as we'll see sort of in this notion of an influence chart, that's really how you're thinking of developing the model should begin. You should start with what is the desired end product and then decompose the logic of the model in a reverse fashion. So again, you want to ask these questions. Make sure you're going to build a model that at the end of the day is going to provide the user to be able to put inputs into the model and get meaningful outputs. And again, this influence chart that we have actually a separate video that talks about the construction of an influence chart. I just find this to be incredibly valuable. It's a pencil and paper exercise basically, but it allows you to start off on the right foot in terms of model development. And furthermore, if you do a good job in terms of constructing an influence chart, to take that paper influence chart and actually bring it to life in a spreadsheet model is really easy and straightforward. If you don't do that, you're going to be burning a lot of time later on sort of iterating through debugging the model. So the influence chart, and again, there's a separate video that sort of leads you through the construction of an influence chart. It's a simple diagram to show outputs and how they are calculated from inputs. And again, I find it great, especially for complex unstructured problems, because it's it's not getting into the specifics or the functions involved or the distributions involved. It's really just sort of taking it at a simpler level and just kind of saying, what would affect sales? What would influence sales? So the number of units sold for something may very well be a function of the price you set for that product. So if you tell me the price and then you tell me some elasticity relationship, then I can estimate volume. In other words, you only need those two things to be able to calculate the third thing, which is the number of units that you might sell. So again, we do this as an early step, and again, if you do it well, then developing the spreadsheet model to support it is straightforward. It has you identifying the main elements of the model so you don't get bogged down into minutia that's not really that important. At the same time, it makes sure you don't miss anything that is important, and it delineates the boundaries of the model. In other words, it establishes the scope of the model. Where you sort of what's on the table and what's not in this model, what's being considered and what's not. It's a great tool for communication as well. And again, I recommend this as really step 0 for any formulation or modeling task. And make a comment here that says ignores all available and or unavailable data, by the way. And available data is the stuff that but there's other data and relationships that you don't know, but they have an effect. Like, for example, elasticity. The higher the price, the fewer the numbers of units you may be able to sell. Well, there's not too many businesses that really have a good handle on a function for elasticity, but nevertheless, you can't ignore it. You put a placeholder in the model that just says, hey, we price it too high, it's going to reduce the demand. Price it too low, we're going to exceed our capacity, for example. Also, as we construct it, the convention is you just start at the top with the main output, and then you go from top to bottom, or you start on the right and you explode back to the left. And again, there's conventions in terms of symbols that we use. We usually have sort of the final output as a hexagon, and then we've got sort of decision variables along the way where you're going to have to make a decision, put an input in, what is going to be the price, etc. How many are you going to produce? Things like that would be in a box. Inputs, which would typically be sort of like parameters or data provided, those usually have the symbol of a triangle. And then what we call the intermediate variables, in other words, these sort of summations as you go through the model and so forth. Usually just treat those as circles. So you think about it, you kind of got a hexagon on the far right saying this is your key output. On the far left would probably be things like the inputs, the data and so forth. Somewhere in there are the square or the rectangular decision elements, and then sprinkled all throughout would be these sort of intermediate calculations in the form of circles. And again, check out the other video. It does a good job of presenting that. But the principles are, again, you start with the final outcome, and then you decompose that outcome measure into just the few variables that would directly determine it. In other words, you say, like total profit is your outcome. You just say, well, what would I need? What are the couple of things I would need to calculate that? Well, total profit, if you give me total revenue and you give me total costs, then I can calculate total profit. So that then creates, two intermediate values, which is total revenue and one is total costs. And then you say, okay, well, what do I need to calculate total revenue? You go, well, you need the number of units you produce and sell, and you need the selling price per unit. So, in other words, you're really only looking for the 2, 3, or at most 4 things that you would need to calculate an item. And again, you then just decompose back in that fashion. You repeat that decomposition. And finally, you make your way down to the point where it's like, okay, well, you've got a given parameter or an input data, and there's no further decomposition on that. Now, one principle with influence charts is that, again, there should not be redundancy in terms of the particular data elements or outputs or intermediate values or decisions. In other words, a variable basically should only appear once, but it can clearly influence several other variables. So, for example, price is perhaps a decision variable that you're going to choose. You're going to choose price, but price is going to influence demand, perhaps, and demand and production are going to influence the number of units that you sell. So in that respect, price, again, there may be more than one arrow emanating from an element because it clearly is affecting a number of things. So again, price is going to influence revenue, but it's also going to influence demand in terms of number of units. So again, be very clear on the units for each element. This is something that's kind of usually overlooked or left off, but it turns out it's super important as you move from an influence chart to a spreadsheet. If you're not clear on your units in the influence chart, you may very well make a units mistake in the construction of the spreadsheet model. So I'm kind of really very firm on that because I've worked on a lot of projects where it turns out someone just gets their units a little mixed up and you get crazy numbers, and sometimes you catch them and sometimes you don't. We saw an example of that actually in the first class when we were having people estimate the number of squash balls that would fit into the room. If you recall, there were estimates of 40 or 50 or 60,000 up to 16 million. Well, clearly there's some problems in terms of with the units of measure there. So part of that planning, by the way, also is go ahead and, again, before you start cranking away on the spreadsheet, do some calculations by hand. Make sure you could sort of provide calculations or estimates for the various items just with pencil and paper. In other words, you don't want to have an error in terms of encoding it into formulas in a spreadsheet model sort of alone. You want to be able to have a point of comparison with respect to that. So again, just pick some numbers for the changing cells and determine what the results should be. So yeah, if you say, okay, we're going to make a production mix decision, and go ahead and work your way through what should be the resulting profit estimate for a given set of production amounts. So another principle also is start with a small version. Again, the key thing is to sort of build it out from simple and small to complex and large. And so, like in the case that was covered in the chapter, the Everglades problem, it said what it first did was build out just a couple of years and make sure that all the cash flows were being accounted for properly. And then from there, it's pretty straightforward to copy it down to encompass the entire 10 years of the problem. So test. So once you develop the model, what you want to do is you want to stress test it and try the extreme values. And this is very important, especially as we start to get into relationships that are what we call nonlinear. Like, for example, elasticity. If you are creating a model that involves price elasticity, in other words, the demand is going to be a function of the price. You think about that. You price it way high, then the demand should drop to zero. And if you price it way low, the demand should go, considerably higher, like, perhaps towards infinity or whatever. So you want to check sort of extreme values for that. So, and you do that with, large numbers, small numbers, unit numbers, and so forth. And again, once you've tested that small version and so forth, then copy the formulas, expand it to the full version, and continue to test it in that, sort of stress test it in that way. Now, the example through the chapter was this Everglade cash flow problem, and what it was is they had a projected cash flow each year for 10 years. It varied from a negative number to they would have a surplus amount of cash coming in. And so the trick was, or the sort of the decision here was, they can't meet their cash flow requirements without some amount of loans. And there were two basic options on the loans. One was a 10-year loan that would kind of cover that entire period, and it had a low interest rate of 5%. Or you could do a series of 1-year loans over a subset of the years. And so, if you sit way back from that, you go, okay, well, what they're really trying to figure out, what the sort of end product is to help them make decisions in terms of which loans and how much and when should they take these loans out in order to, to minimize the eventual interest rates and therefore maximize their cash position after 10 years. In other words, cover their cash flow needs, but do so as inexpensively as possible so that you've got the maximum amount of cash in hand at the end. So, you would have sort of done an influence chart in terms of what does it take to calculate the ending balance. And you would have said, oh, okay, well, to calculate the ending balance, I need the balance of the year before. I need to know what amounts I paid out this past year. I need to know what new short-term 1-year loans I took out last year. And I need to deduct any interest payments that I had to make during that year. So you can decompose back in terms of what you need for that output, which is really, again, the ending balance, say, at the end of each year. And then you move to sketching out the spreadsheet. In other words, what it should look like, and in this case, you're just there's conservation of money here. You've got an ending balance, you've got cash flowing in or out, you've got long-term or short-term loans that you may incur. You have to service those loans with interest and payback. And so it all just, you just got to keep track of those cash flows as they go through. So before you even start putting in numbers or data and calculations and so forth, you just envision what the spreadsheet model would look like. And again, as we said, you can start small, start with just a couple years, make sure everything's calculating out correctly, and so forth. And then you build out the full version of the model, and then you start to analyze it. And again, you're making sure that everything is working accordingly, and you test various values, propose solutions in this case. Now again, we've been talking about descriptive models up to now. We're not getting into prescriptive models yet. Again, my premise is that if you can do the key thing for you guys to start with is to get a good descriptive model building capability in place. If you do that, then it's really a simple matter to add the prescriptive piece on top of that. So the chapter also provides some guidelines for building good spreadsheet models. And it says enter the data first. Well, after you sketch out and do an influence chart for the logic and everything like that, then you again enter the data that that you have and it's going to be involved in the spreadsheet. And again, these are sort of known things. You only want to enter them once. You want to well label them. You want to use named ranges to refer to them. So, and of course, use, formatting and grouping and so forth to organize that data. And, put parameters, you've got, say, pricing parameters or production parameters, etc. You want to keep those in logical groups. And if it's, by product or by year, you want to sort of organize it in this sort of matrix format. And again, you don't want to have redundancy, because if you do need to change a value later on, you only want to do that in one place. So if you've got a piece of data which represents a parameter that goes into your model, don't put that in formulas. Don't key in the number into formulas. Instead, just put that data element into a single cell, label it next to it, and name that range according to that particular parameter. Again, later on, if you say, oh, our estimate for cost per, board was wrong, then there's only one place you need to go in and make that change. If it's buried in a bunch of formulas as a value, then that's going to be a problem. Also, again, you want to separate the data from formulas. So the data should take on a certain location and shade of formatting, for example, in your spreadsheet. But over here, these intermediate calculations, and those should not include any numbers in them. In other words, numbers like parameters shouldn't be in there. They should be in their own cells and named ranges. So again, keep those separate. And also, it's easy when you use some of the auditing tools to look at the formulas. You're looking at sort of English language descriptions of the various components of a formula, rather than a bunch of sort of numbers that would have to make you rely on what they actually stood for. And again, keep it simple. Avoid what we call power functions, which are sometimes these big, huge nested if loops and things like that. Just try to make it as simple as possible. So, break your complicated calculations into a bunch of smaller subtotals. And again, what's nice is the influence chart. If you start with that, and like I said, it only says, well, what are the 2 or 3 or 4 things required to calculate something? Then that by itself is biasing you towards a sort of simpler building up of formulas. And again, range names are super important. Again, and make them as descriptive as possible, but not too long. Because again, at the end of the day, ideally you're looking at a formula and you've got concise yet very specific and clear descriptors in terms of named ranges for that. Of course, use relative and absolute references to simplify copying formulas. Use the $ selectively. When you're copying formulas and so forth. I assume you guys have had a lot of exposure to that. If not, then let me know, or I can point you towards some resources for that. Border shading, colors, distinguished cell types. Again, you can create your own convention. Just make sure that it's clear and easy to use. And this actually applies this notion of show entire model on a spreadsheet. The data should be sort of in one area of the spreadsheet. Constraints should be clear and so forth. And for a lot of the models that we're going to work on here in this class, you can fit them all onto one spreadsheet. And Solver turns out, which is what we use for prescriptive modeling later on, it really needs all the stuff to be on one sheet. So there are other conventions for making spreadsheet models where you use different worksheets for a model. Like you have one worksheet just for the parameters and the constants, and you have another one just for the intermediate calculations. Then you've got another one which is the manager page, which is where you put inputs and you get outputs. And we'll show you examples of those as we go. But just, for now though, it's probably best to just show the entire model on a spreadsheet. So again, you should be able to immediately identify, like you look at it, go, okay, those are the data, that's the intermediate changing cells, and here's the objective that we're trying to accomplish. Include constraints and limits, and sometimes, like I said, put in those flag values to give you a heads up if you're violating a constraint. And again, the calculation should be easy. Now, the chapter alludes to some of the auditing tools within Excel, which are really cool. There's you've got a toggle in terms of showing the formulas, and that is if you just hold down Control and tilde, then it'll show the formulas in the cells rather than the values, and that makes it easy to debug as well. Another one, by the way, are the trace precedence or trace dependence. And these are nice. And actually, let me just shell out to Excel, and I'll show you what that looks like. So this is the Everglade cache management flow problem. So if we pick the ending balance here, and I say trace precedence, then what it does is it says, okay, what are the values that go into that calculation? And it turns out that the values are the ending balance of the period before and the sum, as illustrated by the light blue box here, the sum of all the values along that row, that the blue line is spanning. So that's cool. You can remove that then. You can also trace dependence. In other words, what later formulas need that particular value. So for example, the only place that cell J13 is used is in the formula for J14. So it's looking, one is, what is used to calculate a value, the other is where is this value used later on in calculations. And we can remove that. Again, the toggle for showing formulas or not is simply either that Control tilde, or you just use this button up here on the ribbon called Show Formulas. When you do that, it then shows all the complete set of the formulas. And if you toggle back, it just returns you back to normal, just showing the values in there. There's also error checking and evaluate formulas, which allow you to, it does kind of a quick audit on the worksheet to look for any possible errors. Like if I say error checking on here, it just says, hey, J11 right here, it has numbers to the side of it. So in other words, it's kind of picked up the fact that a lot of these other ones, like it's just kind of warning you that, hey, maybe this formula is missing some, it's got a calculation of summation of C11 to I11, but there's no values in there. So it's not causing us a problem, it's just kind of giving you a heads up on that. Another one is evaluate formula, which is pretty interesting, and that is, it just allows you to sort of step back for a calculation. So if I select this cell, we've got a value of 3.01, I evaluate formula. Well, that 3.01 is calculated from the previous balance, which is J15, plus the sum of the row 16, basically. But what it does is it says, okay, that's the calculation for that cell, but the one that's underlined in here, then if you click evaluate, it will now say, well, how did we get J15? And J15 is equal to 0.31 plus the summation on row 16. So it starts to just break these values out. And now it breaks out this sum C16, which is now, again, that totals 2.7, which is the 3 minus the 0.3. So those just allow you to kind of step back if you're like, man, I'm getting a crazy number here. and it allows you to just simply break it out by its components and see where maybe it's gone wrong. Now, the good news is you don't need that very often if, in fact, you have sort of decomposed your problem into smaller chunks of calculations. So anyway, these are just some heads up, some summaries of the chapter 4. You'll get a chance to apply these in some practice problems and some of the things that we do in class. So thanks for listening, and we'll see you in class. Thanks.